All right, back to this week's assignment. We're going to try a few more problems here. Now, in this case, we're given f of x, and we have to find the inverse of f of x. So I'm going to walk you through a few of these problems, including some difficult ones. What I recommend you do is do these problems along with me. That way you can get the hang of the steps involved, as well as maybe be able to pick up some mistakes or, misconceptions you might have. Start with the first one here. All right, so we're not given y here. We're given f of x, and we're given x. Again, the same thing we're looking at, though. We're going to be doing the same thing here. We're going to be taking f of x. We're going to be swapping it out with x. Because basically f of x, it's an output. It's the same thing as y. So I'm just going to rewrite this as 3x minus 3. And then just like we did before, I'm going to swap them out. So I'm going to have x over here, and I get 3y minus 3. And then I'm just going to isolate y. To get there, I'm going to add 3 to each side. And it's always good to draw that line. At least I find that helps a lot of people. All right, I'm just going to shrink it down so I have a little more room. Then I get x plus 3 here equals 3y. Now to get that y alone, since it's 3y, that means multiplication is happening, I'm going to divide. Instead of dividing the whole thing, which I can do, I'm going to divide each piece by 3. It's the same thing. I'm just distributing my division. And then I get x over 3 plus 3 over 3 simplifies to 1. 3 over 3, as I said, simplifies to 1, so I get y. And I'm going to take it one step further. This is a pretty good answer, don't get me wrong. But if I had to graph this, I want it in slope-intercept form. That'd probably be much more helpful. So what I'm going to do is instead of x over 3, I'm going to make that 1 over 3x plus 1 equals y. Because as I went over in the last video, right, when you're multiplying fractions, just multiply the top numbers. Because x, I can make that fraction by putting it as x over 1. Multiply the top numbers. 1 times x gives me x. 3 times 1 gives me 3. So all I did was I rewrote this in slope-intercept form, which is going to be helpful when you're going to be graphing these. All right, so I got 1/3 x plus 1 equals y. This can be a bit tricky, so you're going to notice we have a number of problems here. Some of them involve fractions. So what I'm going to do is I'm going to go through a few, so that way hopefully it helps you out a little bit. The next one I'm going to do is number 9 here. And actually, before I did that, I'm going to do one final step here. I forgot to do one small step. It's a small step, but it's an important one. And I'm glad I caught myself. I want to do that. There we go. I'm going to keep it as it is. I'm just going to write this as f of x instead of y. I'm going to turn it back to f of x. Why? They're basically the same thing. They're just outputs. I see some people, they like to rewrite the format too. You can do that. You can rewrite it as f of x equals 1/3 x plus 1. I haven't changed anything. All I did was I swapped, what was on each side, the equal sign. Sometimes people like it in this format. Sometimes people like it in the other. Neither one is wrong, so. All right, now we're going to get to this one. So, once again, I'm going to change this to y. I get 1/5 x minus 10. Again, to find the inverse, I'm going to swap my x and y. X goes here, y goes here. I get 1/5 y minus 10. All right, and now it's all about isolating the y. I'm going to shrink this down a little bit. I might need a little bit of space. All right, so I'm going to draw a line here. My first step, I'm going to add 10 to each side. These cancel out. I'm left with x plus 10 equals 1/5 y. Now to get rid of 1/5 y, I'm going to multiply each side by the reciprocal. Now I could divide by 1/5, which, a lot of people would do that, and there's nothing wrong with that. When you're dividing by a fraction, you're just really multiplying by the reciprocal anyway, so that's what I'm going to do. Multiply each side by 5 over 1. So multiplying this term by 5 over 1. And I'm going to multiply this whole thing here times 5 over 1. I don't even necessarily need to write it as 5 over 1 because I don't have fractions here. All right, these cancel out, and I'm just left with y over here. I like that. And then I'm going to distribute. Don't forget to distribute. 5x plus 5 times 10 gives me 50. So I can shrink this down. And I'm just about done. I'm going to replace y with f of x. Again, just using function notation. 5x plus 50 equals f of x. And then, I'm just going to swap places. I like to see it like this. So I'm going to put the f of x here. I'm going to put the 5x plus 50 here. Some teachers prefer seeing it that way. Some students prefer seeing it that way. Either way, it's the same thing. I didn't change anything. I just switched what was on each side of the equal sign. All right, so hopefully you're getting the hang of this a little bit. I'm going to do another one with you. Let's do, all right, number 12. All right, so step 1. I'm going to take f of x. I'm going to replace that with y. Makes it a little easier for me to digest. I've got x minus 2 here over 5. And my next step is I'm going to swap the y and the x. Because again, for inverse functions, inverse relations, you're swapping your input and output. All right. Now, the first step most people would be inclined to do, they would say, I want to get rid of my subtraction first. But you're going to notice that this whole y over 2, it's over 5, the whole thing. You almost want to consider that a grouping symbol. If it's on top of, if it's basically a fraction like this, if the whole thing is being divided, that's a grouping symbol. So you want to get rid of that first. So I'm going to get rid of dividing by 5 by multiplying by 5. I'm going to do that to each side here. What happens is these cancel out. And I'm left with 5x here. And over here I'm left with y minus 2. Now to get the y alone, I'm going to add 2 to each side. Then you get 5x plus 2 equals y. I'm just about done. I'm going to change my y to f of x. 5x plus 2. And again, you can swap places, so you can put the f of x over here and the 5x plus 2 on the other side. But this is a key mistake a lot of people make. Their first instinct would be to add 2 to each side. But what you want to watch out for is, as I said, the whole thing is being divided by 5. If the whole thing is being divided by 5, you want to get rid of that dividing by 5 by multiplying by 5. I've seen people do it this way too. They'll distribute the division, which isn't necessarily wrong. I'll show you what I mean. Instead, they might write it out as x equals y over 5 minus 2/5. Then they go about using fractions, like adding 2/5 to each side, which isn't a bad idea. You can do that, and I'll show you how you can get away with doing that. You get x equals y over 5. Oh, don't forget, I added 2/5 to each side. And then you can multiply everything by 5. And you notice I'm basically going to get the same answer here. 5x, 2/5, these 5's cancel out, I end up with 2, equals y. I end up with the same thing here. So you can either distribute your division and then solve it like so. The only thing is it involves fractions, which can lead to some mistakes. Or you can just get rid of it at the very beginning, and then that makes it a little bit easier. So, all right, we ended up going through about 3 examples here. Hopefully this gives you some groundwork to work with when it comes to these problems. Again, I know they're not easy. These can be very difficult because essentially what you're doing is you got a couple steps going on. You got to swap inputs and outputs, and then you got to deal with literal equations. Trying to isolate y involves a lot of inverse operations. It's really easy to make a mistake while doing that. So again, if that happens, don't worry about it. It's okay. The goal is you just want to have down this step of swapping your inputs and outputs, and hopefully with the more practice you get, you'll notice less operational mistakes. Again, if you have any questions, you can always reach out to me.